So this is the basement, road level, ground floor, first floor, and terrace. These are the levels that we have got. So now, what is the height that's available over here? 29 feet. You agree? So this level is 29 feet. So from the road level, we have got height of 29 feet. We have to consider for the building. So let's go to NBC now. Okay. NBC.
Sir, I am not able to see the screen.
What about others?
We can.
Can means probably issue is with you, buddy. You might have to disconnect and connect back once.
Yeah, now it's okay. Now it's okay.
Okay. I mean, you're using mobile data, is it?
No, no, Wi-Fi only.
Okay, sure. Take care. See the internet, check the internet speed, please. Anyway, so this is basement, road level, ground floor, first floor, and terrace. So for this, we have to work on the project. So let's go to NBC code. So volume one. So what kind of classification will come under if it's a hospital?
Hospital, institutional.
Yes, absolutely. So we have to refer institutional building. So this is industrial. This is moderate hazard, a storage building, hazardous hedge. Just a second. Mercantile, assembly building. Yeah, institutional buildings we have to consider. So institutional buildings less than 59 meters with a plot area up to 1,000 square meters. Now, what is this area? Like, what is this particular one we have to consider?
Less than
Uh,
10 meters it is there. Less than
just a
15
second.
meters. Less than
Less
15
than
meters.
50 meters, Alva,
29
just
feet. Around 9 meters.
around 9 meters height. So yeah, I'll do one thing. I'll just write an Excel sheet. Is that okay? Requirement. Okay. So our this thing is lesser than 15 meters, but is the area of the plot is greater than or less than 1,000 square meters is what we have to take. Okay, with plot area up to 1,000 square meters. So if the plot area is up to 1,000 square meters means if it is, I'll create a new layer. That's right. Let's take a red color or yellow color. Yeah. Already created firefighting, is it? Okay. Hmm. Then, so now what we'll do is we'll draw this thing. So let's say I've got an area because this becomes my plot area, right? Roughly, if I don't have any boundary wall. Yes or no?
Yeah.
This entire thing, you have to take it as my plot area roughly.
We should consider side boundary, right?
Yeah, boundary, but actually here in this case, we don't have any this thing. What you mean to say is there's a boundary wall for this
Okay, but
project
usually the
because it's
side
a part of a bigger
boundary.
campus. So that's the reason I've taken an external entire boundary,
Okay.
which can be considered as a campus in this case. Understood?
Okay, if it is a single building means we go
Then the
to
boundary
side boundary.
wall internal is what you have to take it. Yes. Of course, it's again argumentative. So yeah. So what is the area that we have got?
Mhm.
5,005. So divided by 10, 55,989. 55,989 divided by 10.76, alva.
Yes.
So it will be 5203 area, 5,203 square meters. You agree?
Yeah.
So if it is, just a sec, yeah. So our area of the plot is 5,000 square meters. So definitely you have to go to the next one. Not up to 1,000 square meters, have to increase the area, not building area. Yes or no?
Yes.
So in that case, we have to refer up to ground floor. So obviously, have to consider less than 15 meters in height with a plot area of more than 1,000 square meters. So now don't you think you have to consider this one?
Yes.
So here, if you see, you require the following things. You require fire extinguisher, first aid hose reel, wet razor, downcomer, yard hydrant, automatic sprinkler system. Manually is required, automatic is required, means it comes under automatic plus manual only. And then you have got your underground tank capacity is also required, terrace tank is also required, pump is obviously required, and terrace tank level, actually it's not required in this case. Understood or not?
Okay.
But again, if the pressure is unable to meet 3.5 meters as per height, we might have to install. Because at the end of the day, we should get that minimum pressure. Am I clear?
Okay.
Okay, so they have not, even though they have not provided, we generally provide it with a booster pump if required. Clear?
Yes.
So now we are going to, understand about, how to arrive at this particular one, how to, so basically we'll just write it. I guess that will be better. Generally, for any project, if I have it, I'll try to mark it something like this. Just a second. HVAC home. Okay. Just wanted to copy something in this. Nothing else. Yeah. Fine. So serial number 1, what is it? What is this campus? A dental college, right?
Yes.
So obviously I have to take it as classification. So classification is obviously what kind of hazard it is. So dental college, all those things will come under obviously light hazard. Hazard. And building height is how much?
9
Is equal to
less than
29 divided by 3.28. So that's
9
around 8.84 feet. So in this case, oh, close it. So here, let's write. So basically, we require fire extinguisher.
Yes.
Yes. And
Yes.
first aid hose reel. Yes. Wet razor. Yes.
Yes.
Downcomer.
No.
No, because wet razor, if it is there, downcomer is definitely not required. Yard hydrant. Yes. Sprinkler system.
Yes.
Yes. Manual alarm.
Yes, yes.
Required C note 1.
C note 1. So manual operated electron. Of course, when this is required, you can directly take it as R. Note 1 probably says, what is the page number? I remember. What is the page number? This one, alwa, huh? Page number 299. Huh. Note 1 says, host system shall be included talkback system and public address system for occupants given table 1 to 3. Define the building 15 meters above in height, except for A3, A4 occupancy shall be provided for the building height of 24, 25. So basically, even to define all buildings 15 meters and above in height, except in A3 and F4, where shall be provided building height about 24 meters. So this is exactly not required to have this one. What you meant to say is because of the building is required above 15 meters, then only this talkback system is required. Else this talkback is not required. 5 talkback system. Okay. That's we need not really worry about it. And then we have to worry about your this one. So this is also required. Yes. Yes. And then you have got your UGT. Your UGT is required. So what is the capacity of the underground tank here?
100 kL.
100 KLD they have given, but we have to check it once. Just because they provided might not be correct. 100,000, 10,000 lakh, 1 lakh liters. OHT is there, that is 10,000.
10,000.
And then pump at UGT, we have to see note 14. And at terrace, as per NBC, it's not required, but we might have to consider it. And some people won't even install it because as the NBC said so. Because as per NFPA, you don't have this concept of overhead tank in the first place. But NFPA, you don't have this overhead tank. Anyway, so we'll go to this pump at underground tank. Pump at
Chaitanya,
UGT. Yes, sir.
Chaitanya, what is that? As to NFA, there is no overhead tank. What is that actually?
What is it? I didn't get you.
No, as per NFPA, you told there is no overhead tank, no?
Overhead tank is not there as per NFPA. Yes.
In any building?
Yeah, in any building, you don't have any overhead tank as per NFPA, except when you don't have underground tank, then you'll have OHT. Hello?
So it's like
When you
either
don't have
you'll have
underground
used
tank, like like what do you call this one downcomer? If it is there, then you have it. Else, it's not required.
okay, either you'll have your UG tank or your overhead tank. That's all in as per
Overhead tank.
NFPA.
Yes, yes, yes.
Okay.
But only thing is your tank capacities and all are actually a bit huge in NFPA.
Okay.
And your pumps are more stringent. In fact, the cost wise, it will inflate almost 70%, it will be higher. Your pumps and all, if it's NFPA compliant.
Okay.
Because NFPA should have UL listing. For that, a lot of safety features should be added to your pump motor.
Okay.
Okay. Anyway, so this is number one. And then we'll have a yeah. So now we'll go to required anyway. See note 14. You have to refer note 14 again. So note 14 says provide required number of sets of pump, each consider one electric, one diesel of 1620 LPM and one electrical pump of 180 LPM. Understood? So I'll write yes, but then here I'll write what is it required. So I require two number of pumps, one electric, one diesel with a capacity of 1620 LPM. Plus one diesel of 1620 LPM, 1620 LPM. And then I've got a jockey of 180 LPM. Jockey of 180 LPM. So I require these three pumps. Am I clear?
Yes.
Okay, so now if I wanted to really work on this particular one, so we have to provide all these things. So let's worry whether our whether this particular flow rate is actually sufficient or not. Let's go to that part.
Yeah.
Okay. And project to October 2025. Fire PPTs will go. So made a system selection PPT. So I've actually taken a snapshot. I've taken snapshots of IS codes. Okay. This one is whenever is required, I'll be adding the slides as of now. Just do it like that. Anyway. So first and foremost thing is we have to calculate the AMAO. That's basically area of maximum operation. We call it as. Okay. So we have to calculate the AMAO and then we have to decide. Am I clear? So as per sprinkler system, if we take, we'll go to IS code just for the cover. We'll just go to IS code. BS codes, IS 15105. For classification, understanding the classification in a detailed way. Of course, as per NBC, it obviously comes under this thing, light hazard. This classification of occupancies. So we've got the following ones. Classification of occupancies, if you see, Light hazard. So light hazard means light hazard occupation shall be understood with low flow loads, and obviously hospital and all means you have a very less this thing, right?
Less hazardous it is. Yes.
Less hazard, yes. But now no single compartment shall be greater than 126 meters and allow within the light hazard occupancy such as can be fire separated by walls with a 30 minutes fire rating indoors. Now we have to see whether do we have any room space or anything whose area is greater than 126 square meters. That's 1,200 after all. You agree?
Yeah.
So this is one zone, let's say, because general 30 minutes fire rating, any door could be, you'll be able to get. 2 hours, you'll get 5 doors. 30 minutes, it's simple actually. But anyway, what is this area? Let's see. 1570 square feet. So calculate 157 divided by 10.7600. That will become, sorry, 10.76. So that's around 14.
1.70.
Sorry, let's just a second. What is it? Oh, 1570. Okay. 570 divided by 10.76 means 8. Sorry.
145 square meters.
Yeah, obviously it will be 145.9, 146 square meters. So each zone is greater than 120 for sure or
Yes.
not? 126 square
Yes.
meters. So
Yes, it is.
obviously we
Yes.
have to push it under ordinary hazard. Am I clear?
Yeah.
Okay. So as this compartment has greater than this one, obviously for this reason, just for my light hazard, I can't introduce partition walls, right?
Mhm.
Which will be stupid of us. So for that reason, we have to consider as ordinary hazard. Am I clear?
Yes.
Only as per sprinkler system, it is ordinary hazard. But for other systems, again, it's light hazard. Am I clear?
Mm. Yes.
Mm.
So now we have to consider this as ordinary hazard. Okay. Now we have to calculate what is the flow rate required for sprinklers and what is the flow rate required for hydrant system. And then we'll design the pump capacities. We'll cross check with this. Whichever is highest, we have to take as per NBC or as per our calculations. Am I clear?
Yeah.
Now your AMAO calculations. Okay. So basically your AMAO is nothing but area of maximum operation. Okay, if you remember the charts, you had that, right? So similarly, we have used for IS codes. We have, I mean, you remember 1500 SFT like that?
Yeah. Yeah.
So like that, we have to consider this as per IS codes. That's almost like NFPA only. Whatever the hydraulic calculations are taught, that particular sheet is actually taken from NFPA. This one is as per IS codes. Am I clear? Of course, the methodology is same. Its only thing is we roughly estimate it instead of doing hydraulic as a France. Clear? Now, in this case, if you see the density of the discharge, if you read the text properly, the density of water discharge and design area of operation shall be minimum of 5 LPM per meter square at over maximum area of 360 square meters. If the area is lesser than 360 also, you should be considering it as 360 square meters anyway. Clear?
Okay. Clear.
So
Yeah.
considering this, we have to take it. So now, what is the area we have to take? 360 square meters, right? So area to be considered is 360 square meters. Now, what is the flow rate minimum I require?
5 LPM.
5 LPM. So flow or density is how much? 5 LPM.
5 LP.
LPM, 5 liters per minute, and this is meter square. Now we have to take, what is the other thing that we have to take? We have to take the volume of water. So if you take volume of water, that is nothing but is equal to area into density. That will become as 1800. Minimum volume is what I require. Yes or no?
This is per
So,
minute, right?
360 square, 1800 LPM is per minute I require. Yes or no?
Yeah. Yeah.
Yeah.
So you have already increased your bloody electrical pump as 1620 LPM to 1800 LPM in this case. Am I clear?
Okay,
Understood or not?
Yeah.
got
If it was light hazard, then it's different. If it was, let's say, if it is 8 hazard, then it will be 84. I'm just assuming if it is light hazard, just wanted to explain you here. So in this case, you can refer 84 and 2.25. 84, 2.25. So is equal to this into this. Then only 189 LPM is fine in this. So is sufficient in this case. Understood?
Yeah.
But anyway, in this case, we have to consider 1800 LPM. Now, next element that we have to consider here is after this particular thing is there, you have to take as per sprinklers also. Understood?
Okay.
So, what should we take is basically area of protection. How much is area of protection we have to take? For light hazard, each sprinkler can cover 21 square meters. You can see 9.17.1.
Yeah.
Right. So
Mm.
light hazard is 21 square meters, ordinary hazard is 12 square meters. So now we have to do the next one, which is your ordinary hazard. Your ordinary hazard, we have to take ordinary hazard only. The next option of selecting the flow rate is basically you have to take your ordinary hazard. So your ordinary hazard is how much? 12 square meters, Alva. So,
Mm.
so ordinary hazard, if it is 12 square meters, I mean each sprinkler coverage area. Range area by sprinklers is 12 square meters. Right.
Yes.
Now, minimum number of sprinklers, how much you have to take? Your total area of protection by number of sprinklers? Because you should protect an area of 360, right? Your
360.
area of coverage. Worst case, divided by 12. So automatically 30 numbers you got it.
30 numbers.
Understood? Then we have to worry about the next element, which is your K factor. So for this case, generally your building is a normal height means you generally consider your K factor as 5.6 in most of the cases. Your K factor, there should be somewhere. K factor, I didn't mark it, is it? If you remember the previous slides, I marked the K factor from NIS code itself. If you remember, there's a clause even for K factors according to your storages and all. You remember?
Yeah.
K 1.16 or we have to take those values anyway. Let's go to that particular slide instead of searching here. This particular one. So we have to take as your your general flow rate, your general this thing is Q. We have to take it. So K factor is 57 or 80. We have to take it. Yes or no? Up to
Correct.
9 meters height. So our building height of the building in the sense height of the particular floor. What he meant is here, not the entire building, because we're least bothered about the entire building for a sprinkler, right? In a floor, when you install it, that like in that particular floor, it will fall. You understand it?
Yes.
So for that
Yeah.
reason, it's up to 9 meters only. Our building is hardly 3.5 meters like that. I mean, each floor. Right? So if we take ordinary hazard, we have to consider for ordinary hazard. If we take it, that will be 80 or 115. So we will take 80. Is it fine?
Yeah.
Okay. So we can take up to 9 meters means we can 80 or 150. So I'll choose 80 for my ease because obviously it will have a lesser flow rate. That's the reason. Okay. So K factor is 80. Then the next element that you have is your this thing, what do you call PSI,
Pressure.
the pressure that you have as per NFP as per IS code is minimum 0.5 bar. Okay, minimum 0.5 bar is what you should have. Clear?
It is
That is
this year explained na, Chaitanya, this PSI regarding PSI minimum 0.5 you had explained to us, right? There was one slide on that.
yes. We had this discussion. If you remember, because initially the value also have given it wrong, and then I've corrected it.
Correct.
Yeah. So, but the units were different. At that time, it was 5.6 as a K factor. This is 80. So this is the reason it is 0.5 bar. But in PSI, if it is there, then this will be 5.6 or something. This equivalent value will be 5.6 actually.
Okay.
So Q value, if you take it, Q value is K root Pk into square root of
PS.
56 LPM. So at least I should have 56 LPM. That's value in GPM if you will take it divided by 3.78 GPM, around 14.9 G. If you remember, 15 GPM is what we got it. You remember?
Yeah.
So this is around 56.56 LPM for each sprinklers. So total required flow will be how much? I have to multiply this one with your number of sprinklers.
Yeah.
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 So automatically we come to know 1697 LPM, right? So this is 1697 means 1700 LPM. We can round it off to 1700 LPM.
Yes.
So 1700 is higher or 1800 is higher?
180.
1800. So choose this guy. Understood?
Okay.
Yes.
So you have to choose whichever is highest that you have. So your sprinkler demand is 1800 LPM. You agree?
Yes.
Yeah.
1800 LPM. Yeah. The next element that we have to worry is your hydrant demand as per IS code. So if you really work on the hydrant demand, what you have to do is hydrant. Your hydrant demand is nothing but as per the number of hydrants you have to consider. Okay, so for that also I've made some slide. I've made a screenshots in other IS code. Just a sec. Sunday was preparing this this thing. This is water cutting system that we had. We'll have a discussion later. Don't worry. So yeah, so if you take this hydrant demand, so for light hazard, your pump capacity, basically what you require, because this comes under light hazard as per hydrant or not? Hello?
Chaitanya, one doubt here.
Stop me.
Okay, see what is happening. See, there is word called light, there is word called ordinary, there is word called moderate. Okay.
Yes.
Light is okay, anyways, first that is okay, but this ordinary and moderate is a confusion for us.
Ordinary and moderate is same only, no?
Same only, is it?
See, there are three: light, ordinary, and extra hazard.
Okay.
Your ordinary and moderate is same.
Ordinary, moderate, same. Then okay. We had this confusion yesterday. We were discussing about this. So we had this
Okay.
confusion. Then it's okay. Now go ahead. Go ahead.
Because when you use the term ordinary, you will not have moderate.
Correct. Yes.
So you've got light, ordinary or moderate hazard, and then you have got extra hazard.
Okay.
Or high hazard also. Any of the things you're saying. Here. High hazard is equivalent to your extra hazard areas.
Hmm.
Okay. Now, this particular slide, which is again in IS 13039, that is for hydrant calculations. So if you see, basically, it's clearly given for light hazard, because obviously it comes under light hazard application, right?
Hmm.
Hospital means.
Hmm.
So in light hazard application, your pumping capacity depends on the number of hydrants that you have it. Am I clear?
Okay.
So roughly, roughly we'll take it. Let's say, is it just a sec. Sorry. So if you take this particular one, how many number of hydrants do you think we require is a question? Okay. So the total number of hydrants is what you have to take. Am I clear? I mean, for example, if you have 10 floors, each floor have got 5 into 10 becomes 50. Understood? So
Yeah.
in this case, I'll roughly place it. As of now, we are not locating exact. It's just for a rough estimation. So for hydrants, for internal hydrants, the walking distance will only be 30 meters. You should be able to reach your internal hydrant within 30 meters. Understood?
Yeah.
So let's draw it. Let's say at this location, if I have one, okay, at this location, I'll have one 30 meters under how many feet? 50 feet almost. Cal 30 into, sorry, 100 feet, sorry, 98.4 feet. So
Almost.
this will take 98.4 feet. So this, if we place it over here, then at this location, I might have to have considered one, but that's a walking distance, by the way, mind it. So from here, if some person wants to come, you have to come like this, Alva.
Yes.
Well,
Shortest distance, obviously, not the longer one. Uh, so you have to come like this, Alva. So let's take something over here, or I'll place it over here. Let's take. What is the list? So this is 111. So it is crossing.
100.
It is crossing 100, Alva. Yes or
Yes.
no?
Yes.
yes, yes.
So we have, so because this is the farthest location if you have to consider. So if you place it over here, let's say I wanted to place it over here. I'll place it over here. Then probably it should be sufficient. It is coming as 96 feet. Perfect. But for other areas also we have to refer. Say for example, this area is there. If someone from this area has to come, so he can come like this or not?
Yes.
Automatically we have it 70 feet. So automatically if you place at one location, it should be sufficient. Yes or no?
Yeah.
This area, I'll take one number. It should be near to your exit, but anyway, not much distance is there from the exit, so that's okay. From your fire exit, it's hardly 27 feet, so that's okay. Not a problem. Generally, 5 feet, we say, 5 meters, we say 15 feet, but it's okay. I mean, it's a very minor deviation. Or if I don't want to deviate, one I have to place it over here, one hydrant have to place it over here. Okay? It's again how much risk you want to take it. This is first location. And second location, don't you think you have to really? Okay, let's place it as of now. Let's take it. So here, if you take it from this location, if you place it, let's say this is the entrance. So once this is the entrance, obviously I have to place it near the entrance for sure. So let's take it this location. I placed one number. And again, we'll take one more at this location somewhere over here. Then I've got one more over here. Let's take. So that anyone will be able to reach within that distance. That's the reason. Because the center entry is only from outside, so that's okay. We'll have external hydrant, which should be fine. If you're able to reach from extension, that's fine. So this is the total, I guess this should be sufficient here. But probably here I might require one more because this area is not covered properly. Let's take something like this. We have one more. So these are the
Locating
Yeah.
the hydrant close to the exit or entry applicable to all the hydrants? How is it?
No.
Not like that,
For the
right?
main entrance only, you have to consider.
Okay.
Near main
One aspect.
entrance, you have to provide. Yes. See,
One
see,
aspect.
it's something like this. The psychology was for, I mean, a requirement wise, let's say once a firefighter have come into the building.
Mm.
Say, for example, if you keep it away from the entrance,
Mm.
then will you be able to access it easily?
No, you might not able to notice also.
Notice is one thing because they'll have fire maps, they are trained. But let's say between you and the fire hydrant, if there's a fire, how will you reach?
Yeah.
Understand? Of course, you have one more thing is because that's the reason it's not exact way. So one way of arguing is, let's say if someone says you can actually use external hydrant to quench fire internally to certain extent, alva.
Mhm.
Then also you can. So that's the reason it's not a really point, but generally it's a good practice if you keep it within 5 meters of your entrance.
Okay. And second thing is this 30 meters, is it the pyrosic distance or what it is you have considered?
I didn't get you, sorry.
30 locating hydrant at every 30 meters. No,
Yeah.
that is the logic. What logic is that? Is
No,
that
that is not okay. Logic is also there, but it's there as per standard also. See,
Mm.
each hydrant hose reel cabinet, if you remember, there
Mm.
is something called as hose reel.
That is 30 meters.
Yeah, there are two 15 numbers which could be connected using a connector.
Mm.
So that's the reason it's 30 meters. Okay.
Mm.
The length of the hose reel that you have, the white color, like this one, what I've shown, the canvas hose, whatever I've explained. So that will be of 30 meters length. 15 to 2 numbers will be there. That's the reason. Am I clear?
Okay, Jagmeet. Yeah.
But anyway, it's written in the IS code also. That also I'll show you. Oh, yeah, this is external hydrant. Yeah. In 5.22, the distribution of wetterizer installation in the building should be situation not to be farther than 30 meters from any point in the area. Understood?
Mm. Mm.
And it should be installed in such a way that the height of that particular one between 750 to 1 meter from the FFL.
Okay. IS code is 3844. Is it for internal hydrant?
344 for your internal hydrant. Yes.
Yard hydrant?
Yard hydrant is again external hydrant is 13039.
13039. Okay.
Yeah. Okay.
Yeah.
Because instead of searching for IS codes before you, I've made a snapshot of everything. That's the reason. Nothing else. I'll share you this PPT. Yeah. But I would encourage you guys to read IS codes as well.
So we have to read, otherwise you don't understand.
Yeah, that's what I mean. I'm teaching you some stuff, but there'll be a lot of conditions and there are a lot of applications. Of course, you've got any queries, any point of time, you're free to contact me. Anyway, but I would prefer to use this one. By the way, I guess you guys are aware or not, I don't know. In Rivet, they are because last year I went to this Autodesk this thing. Autodesk Meet. Basically, they invite a few people in the sense like who are in the industry. They feel like who are their customers. They'll call us. So during that one, what they've said is using AI for Revit, not for AutoCAD, obviously. They are basically giving something called as countryside tools, country-wise tools. That means, for example, India, we follow this NBC codes, right? The system knows NBC code. And for example, while designing, if you deviate from NBC code, it will directly highlight it to you, even citing the clause as well.
Okay.
So that they're planning to release this year. I don't know whether they have released it or not yet, but anyway. So that way it will help designers and within few years it will replace designers. That's other part of the story. But yeah, currently it is kind of a aiding tool for designers. By mistake, or I mean, for example, if they're while designing, if they're deviating anything from the line, it will highlight it. And one more thing is, we thoroughly encourage you guys to please work on BIM as well. Because
Okay.
already I could see a lot of projects coming up on BIM itself.
Okay.
Even in our company also, in GMR, we don't use, I mean, for smaller projects, yes, we use AutoCAD. But for the main projects like terminal building or new airport entirely, if it is coming, we are using BIM itself. Please learn, Revit. You can use YouTube or anything which is easy for you to learn. Plus, don't forget to, I mean, at least spend some time on Revit and also try to learn some programming as well. Because using Python, you can automate a lot of stuff. For example, I've got a building something like this. If you want to place manually the sprinklers, how much time do you think it will take? At least it will take 2-3 hours.
Yeah.
Right, 2-3 hours or probably one day only for placing the sprinklers. That's how it depends on the experience anyway. But if you use a script, hardly within 2 minutes, not even 2 minutes, I would say within 1 minute you can place the entire sprinklers and do piping, pipe sizing, everything automatically you can do it. So I know you're a designers from mechanical probably, but still it's better you learn programming. I would thoroughly encourage you because Python is much more easier as well. Okay. As a designer, it will be handy for you within another 1-2 years, at least within 3-4 years for sure. That I can give you a guarantee because I could see outside how everything is running. In design tree, are they doing any automation or nothing as such?
No, nothing as such.
Okay, but abroad it's not the case because we have consultants who are working outside for our airport development. We could see them. So obviously in India also that will come for sure. But anyway, try to learn Python. It hardly takes any time. Daily spend some time. Anyway, let's not go into it. So now how many are there? Basically, 1, 2, 3, 4, 5 other. Of course, in this area we didn't do it, so we have to consider for this guy also. Here I'll place near the staircase. I'll place one 30 meters under. See, 30 meters, right? That's 98 feet. 98 feet. You should got it. So here I might require one more. Let's see. So from here, if I want to do it, it's simple. It's 114. So obviously I require or not? I
Required.
require one over here. One I might require over here. One I might require at this location, obviously. Right? Because of the layout. So now how many I require totally? After this could be avoided if I wanted, but anyway, provided as of now just for numbers, right? 1, 2, 1, 2, 3, 4, 5, 6, 7, 8 are there. Right?
Yeah.
8 plus 8 into how many such floors are there? 2 floors are there.
16.
16. In that, nearly half you require on the terrace anyway.
Correct.
Right? So terrace, if you have half, because generally because the direct distance, you don't have any partitions, that's the reason. So 16 plus again half is how much?
4, 20.
20 you require over here. 20 plus probably at this location, 3 numbers.
23, 24.
24 you require. And then you have got yard hydrants. That's a peripheral one. So let's take from the building, I'll take some 2 meters distance. 2 meters is how many feet? 6 feet approx?
6.7.
Yeah, let's take this roughly. And then what is the length we have it here? Length is how much? 1073 feet,
Yes.
right? Now, in case of light hazard, you have this again. This is for external now I'm speaking about. If you consider your external hydrant, so post shall be provided for every 60 meters external wall in case of light hazard, every 45 meters in case of ordinary hazard, and every 30 meters in case of high hazard building. Now, in our case, it comes under light hazard or not?
Yes.
Yes. So if it is light hazard, then automatically this entire system, total length divided by 60 meters is how many feet is it?
200.
Or reverse, you do, because we have the total length alva. So what is the total length here? We've got it?
170.
1073. So is equal to double 100. Shall we take it? Divided by 3.28. That will become as 355 meters. Divide this value by 60. So around 5.5 means 6 or 7 numbers will round it off because one number plus or minus it will have because of the location issues. Right? When you want to divide it exactly 60 meters, you may not be able to get at site conditions. Right? So you might require 7 numbers of yard hydrants.
Yeah.
And then internal hydrants is how much?
23. 23 is coming.
23 is coming. So total, 23 is internal hydrants.
30.
So your total numbers is how much?
30.
Total numbers is 30. So according to this, your hydrant demand also, we have to worry. So according to this hydrant demand, you can refer it here. So not this one, other slides.
Sir, when it comes to internal hydrants, in hospitals and all, the floors won't be same, right? Means the areas and the traveling
This is the reason, this is just a rough estimation I've given. We are going to design it internally properly. It is
Okay.
just to know the approximate number of hydrants.
Okay.
So, for example, in this case, if you see this slide over here, is it visible?
Yeah.
So light hazard do not exceed, not 20 means 1620 LPM. Exceed 20 but not exceeding 55 means About 27 or whatever number it is between 20 and 55 or not?
Yes.
But at max 23 can become 28, but definitely not above 55 for sure. You agree?
Yeah.
Yeah.
So we'll directly take this 20 to 55, which is 2280 LPM. Understood?
Yeah.
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 So this becomes 2280 LPM. Total number of hydrants is what we have to take. So number of hydrant demand, number of hydrants is how much we got it? 30.
30.
So number of hydrants is 30. We have to take it. Number of hydrants is 30. And what is your this thing you got it? Your this one is 2280 LPM is what you have to take for light
Yes.
hazard. Right. So it is 2280 LPM. You got so hydrant demand is 2280 LPM. Am I clear?
Hmm.
So you have got a value of 2280 LPM. So when you have so now your sprinkler demand is 1800 LPM. Your hydrant demand is 2280 LPM. Am I clear?
Yes.
So your pump should be able to cater to sprinkler system and hydrant system, right?
Correct.
But as I've told you, the minute someone have opened your hydrant, your sprinkler will be shut off. So you have to take highest of the both. So 1800 and 2280, whichever is highest.
2280.
So you have to have a selection of 2280 instead of 1620. Am I clear or not? So though NBC have said you require 1620 LPM, blindly do not follow because you have to follow as per IS codes as well. Whichever is highest that you have to take. Am I clear?
Yeah.
Okay.
NBC never
Chaitanya,
specified the exact. Yes, tell me.
you said one statement I just a few minutes back. Uh,
What is it?
Sprinkler and hydrant shut off. I mean, something you said. Sprinkler will be shut
Right,
off and
right. So
hydrant will be.
basically, the
Huh.
minute firefighters have come into picture,
Hmm.
they'll cut off the supply to sprinkler system.
Okay. Why so?
The reason is, simple thing is basically sprinkler, as I've told you, it cannot direct water on the fire. If the hot air reaches, then it will break.
Okay.
You agree?
Understood.
And do you
Okay.
think at that exact location hot air will be there?
Hmm. 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 Hmm.
I could have fire at one location because of the draft of the air, it can reach, right? So sprinkler is only for very small area of fires, which you're already aware, right?
Correct. Correct.
Yes.
Now, once the firefighters have come into picture, and let's say you have sprinklers as well as the hydrants are running, now don't you think your water will be there only for lesser time or not?
Yes.
So firefighting people are keeping danger their lives as well as others if they still allow sprinklers.
Okay.
Because manually you can throw the water where exactly the fire is. You agree?
Correct. Correct.
For that reason, we have this particular element.
So, Chaitanya, in that case, if the diversity is supplied, then what we do is we use the hydrant system to firefighting only, not the sprinkler system. Correct,
Yeah,
no?
hydrant
Okay.
system only we use it. Yes.
Okay. Second thing, see, you are using hydrant system, but sprinkle is automatic. So what happens inside if there is a fire situation, even sprinkler would have burst and it should be flowing also.
Yes, that's the reason I said you have to isolate it. So once the firefighters come inside your
Uh,
pump room for sprinkler one or external to the building also you can provide. So basically we provide an isolation.
Correct.
So we'll provide isolation valve. So they'll close that butterfly valves.
Okay. So they cut off the water to the sprinkler, then start using only hydrant system.
Only hydrants.
That
Yes.
time this works correct. Okay.
That's what I said. The firefighters once they enter, they'll isolate is the word that we use. That's the reason.
Done, 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 done.
Understood. So anyway, the highest is 18 and this one is 2280 LPM. So we'll take 2280 LPM as our total volume requirement. Understood? Hello.
Yes,
Yes.
Chetan.
Yeah.
Yes, sir.
Yes, correct.
So our pump capacity is 2280 LPM. Clear? The next element that we have to take along with this is we have to understand your your this calculation. What is it? The tank capacity is what we have to understand. Clear? Your tank capacities, you have to either provide for sprinklers. I'm saying whatever rules I'm telling, I didn't make up anything. Everything is available in your IS codes. I just have to give you the correct reference number. That's it. Okay. Just a sec. There's even a code for that as well. This is your pipe sizes. That's okay. Internal hydrant. Just a sec. Sorry. Because we had this discussion previously for the other project that we were working. Just a sec now. All the data. Design jobs. Personnel. PDL. Sorry. Because I mean, exact clause instead of referring, because initially our consultant have given very high volume of water. Then I had to argue, and we had a lot of arguments, and then we had to reduce it because of the budget constraints, as I've told you, for this particular project, cargo terminal project that I've shown. So this is the EBR report. Particular one for firefighting, we have a particular element that we have, because this particular point I've kept it to the consultant, and then we had to we had reduced the volume. Just a sec, no? For demand of the water. Yeah. So basically, yeah, you can see this particular clause 13039 para 5.1.4. We'll directly go there. 13039. Okay. Yes, code 13039. Yeah, external hydrants. Paragraph is, what is a paragraph? It's it. Sorry, the word file alva 1.4.3. So older one, I guess, but let's see. That is the older one, I guess, because 13039 only, na? Para 5.1.4.3. It's not there only. I'll try to download the like an updated ones. Just a sec. 13039 alva. Just a sec. The AS code. What I forgot this thing. It's a problem. Should be. What is it? 13039 alva.
39. Yeah, 2014 edition is there. External hydrants. Download this, but for that you have to log in now. Okay, just a sec. It's a free of cost. You just have to log in. Okay. You guys can actually forgot the. I don't remember password. Let's see. C8DFAA0. Forgot password. 8F9BC. Once I don't rarely use it. Just a sec. I might have got the password anyway.
C 4300 is 43006. Okay. Now what is the thing that we have it? 13039 alva. So I've logged in alva. Okay. A09 E. Yeah. It's captures and I they wanted even at this time after automation. Just it will download the updated version. Yeah. This particular one is the updated version of 2014. We have to always refer updated versions, obviously. This is 5 point, what is it?
1.4.3.
Yeah. So where plants, other facilities are protected by sprinkler system tapped from the pressurized hydrant system. Obviously, right? We have got a single system, alva. Water requirement of sprinkler system shall be determined as per the rules of IS 15105. If the total water requirements exceeds the requirement of the hydrant as per 123, the pumping capacity will be equal to the former. Understood? So whichever is highest, you have to take. Understood or not?
Yes.
That's what I said. That's the reason I've said it. The pumping capacity, we have to take highest of the same. Yeah. So we've got 1800 and this value is 2280. So we have to take highest of the same. Am I clear?
Yes.
Okay. Now coming to the next one is we have to really worry if you have a specific one sprinklers and hydrant as separate pumps anyway whatever we got it according to that only you will refer. Understood? Hello.
Yes. Yes. Yes.
Okay. Now we have to worry about your underground tank capacities. Okay.
Yeah.
So underground capacities, if whatever you have it, you have to calculate as per the time that you require. Now you know your pumping capacity. So now you have to calculate what is the backup time you require. So that also you have a specific code according to which I have to your underground tank capacities also you have whether you want 1 hour backup or 2 hours. 2 hours is the standard one, but you have local fire or fire station is nearby where you have a reliable source only then 1 hour is sufficient. Understood? So then you have to, so per minute is 2280. Then you can multiply with the time, then you will get the total underground tank capacity. That you will compare it with NBC requirement. Whichever is higher, that you have to take it. Am I clear?
Yeah.
Okay. So shall we continue from tomorrow? Because you have to search for that exact code because that time. Just a second. For sufficient fuel tools. Is it internal hydrant or external hydrant? Any one of the cases I had. So I have to just search for it, just give me some time because that particular code exactly where we have it. So if I'm not wrong, that's for 2 hours anyway. Because I wanted to show you with proof. That's the reason. So is it fine? Tomorrow we'll continue. It's already 6:50.
Yeah.
Yeah.
So tomorrow we will basically understand your underground tank capacity and then we are going to work on the design of this project. So near this pump room, we have to work on the pump room design and then we'll work on your yard hydrant location. I'll show you for one floor. I expect you to work on one more floor. Is it fine?
Yes.
Okay, so this will continue from tomorrow, but I hope this is clear. I mean, how to calculate the flow rates and how to calculate the demand of your, I mean, what is your total pump capacities?
Yes.
Understood?
Yeah.
This is how we have to do it as per IS codes. Previously, what I showed you example is, I mean, the hydraulic calculations, what we have precisely done is for your use NFPA, but in this case also you might have to do it if required. But generally, this is what every consultant will do. Clear?
Mm.
Okay, so shall we close now?
Yeah.
Yes.
Okay. Fine, then we'll continue again from tomorrow. Okay, in 5:30 we will meet. Also, hello.
Yes, sir.
Yeah, just a sec. Stop presenting, stop recording as well.